All right, here we go. So it's day 2 of word problems. Like I said, we already talked about projectile motion. Dawson Brady. We already talked about projectile motion, all right, which is where we were graphing kind of like the height versus time, right, of projectiles and stuff like that. And today we're going to be looking at a quadratic situation involving adding borders to, well, rectangles for the most part here. Okay, so let me just show you what I'm talking about. These directions here, don't fret too much about this. It's pretty typical stuff for what we're used to seeing, right? So number 1, it's a good idea when you have a word problem to draw and label a picture if that's necessary, okay? It can be helpful, right? Number 2, define variables. Again, not uncommon, right? Number 3, determine if there's a special formula needed, okay? And then substitute in the given information into the equation. Since we're going to end up with a quadratic here, it might be helpful to write it in standard form, although it may not be necessary, and I'll show you what I mean by that. Number 5 will be solve, okay? 6 will be to eliminate any unreasonable answers, right? Because, like, for example, it doesn't make sense to have -5 feet of carpet, right? So since we're in a context now, we want to be a little more careful. -5 feet of carpet is like, who buys that? You can't, right? And then finally, we'll check our answers. All right, so let's take a look here at number 1. All right, so the length and width of a picture, okay, is 11 by 8. All right, now, again, I told you guys, I don't really care how you draw your pictures, okay? Some people may look at this and say, Mr. Witt, length and width, that's going to look like this. 11 and 8, okay? And some people may look at me and Mr. Witt, no, that's wrong, that's wrong. This is length and width. Okay? I don't really care which one you use. Doesn't matter to me, okay? Because really, it doesn't matter, okay? Just make sure you have one pair of sides, you know, that's 8, one pair of sides, you get 11, okay? So I don't care which one you use here. All right? Yeah. So for this one, I'm going to maybe use this picture right here, okay? Now, John wants to put a picture frame of uniform width. Now, what does uniform width mean? What does that mean? Precise, okay, Anna? What's that? Equal width is another way to say that. Yeah, I'd say that's synonymous, right? Okay? Because sometimes you might have a frame where it's like thinner on like the sides, but then like thicker on the top and bottom or something. You can think about maybe like when you're writing a paper, like the margins and stuff like that. Anyway, uniform width means the same width all the way around. Okay, same thickness, we'll say, all the way around. Okay, so let's take a look at this here then. So we've got, and I'm going to like just redraw it over here now. Okay, 11 by 8, length is 11, width is 8. Okay, so I'm going to say this is what I've got right here. Okay, so I'll say 8 and then 11. Okay? Now, we're going to add this frame around the outside. So I'm going to go ahead and draw that frame around it too. You guys should do that as well. Okay, like so. Okay, and I'm trying my best to make it as uniform thickness. Now, we know that the area of the picture with the picture frame is 180. All right? The area of the picture with the picture frame. So that means this total big rectangle here, right? The whole thing, its area is 180. We already, we don't know the area. Well, I guess we can figure out the area of the small one, but it's the whole area here is going to be 180. Okay? We're trying to determine the width of the picture frame. Ooh, and I can see where this could be. Okay. I'm going to be a little bit careful here. Okay. So, easy as 92. Okay, we'll see. So, what will the dimension, what is this length of the picture frame going to be? Do we know this? Do we know the length of this picture frame? We don't, do we? Okay, sorry. Do we know the width? Do we know this dimension? Do we know this width here of the picture frame? We do not. So how are we supposed to find the area of this thing if we don't know its length and we don't know its width? And that's going to be kind of tricky, right? Okay. do we know how wide? Do we know how wide this frame is? Right here. Okay, it says uniform width. Do we know how wide this picture frame is? We don't. So, let's give it a variable. Let's give it a variable. Let's say that this, from here to here, is a distance of x. Okay? So in other words, we're going to say x is the, what would we say? What we're going to define it to be? X, we would call that the what?
Unknown dimension.
Okay, true. Can we be a little more specific, though? In this case, what is it measuring? The what? The width of the picture frame. So let's say x is the width of the picture frame. Hey, that's what we're trying to find. Determine the width of the picture frame. Okay, cool. We got a variable set up. Okay. Okay. So we know the width of the picture frame is x. So that means this distance is x. But what about this distance right here? What's this distance? Why is it also x?
It's also unknown.
It's a uniform width, okay? Like Anna said, right? Okay, a uniform width means it's like an equal width, okay? So this is also a distance of x right here. So wait a minute, what's this distance right here? What's its measure? X, yeah, okay. So I'm going to go ahead and label that in. And what's this measure right here? X as well, right? It's x all the way around, okay? Except corner to corner. Corner to corner would not be a distance of x, but we're not going to worry about that right now, okay? Okay, so far so good? Now, 180 is another number that we know. It's the area of this whole big rectangle right here. So we know the area is 180, but we've got to figure out like what this distance and what this distance is. Okay, so let's think about this. From here to here, right, from here to here is 11. From here to here is x. From here to here is x, right? So then, what is this length going to be? From here to here is 11, right? Not times 2x. Yes. So this distance from here to here is going to be 11 plus 2x. Do you see it? We have the 11 right here, and we're going to add an x up here, and we're going to add an x down here, right? So here's x. This is 11 right here. Oh, this is really... And here's an x right here.
How'd you get 2x?
Because, so this distance right here is 11, right? But then we have to add onto it an x above and an x below as well. So that's two x's we're adding on, one above and one below, to make this then 11 plus 2x. You see it, the whole length. Okay? Now, let's think about that. Okay, so that makes sense. So then what do you think we're going to say is this length right here, this distance? 8 plus, go ahead, what is it? 8 plus 2x. Again, it's now the 8, and we're going to add an x this way and an x this way. So I can't really squeeze that in. I'm going to try here. Okay, barely fits. Doesn't even fit, really. Okay, I'll zoom in really extreme close-up.
But there's not 2 x's on the top, is there?
Well, let's take a look. Here's the 8, right? But then to expand to the bigger rectangle, from the 8, I got to go x this way and an x this way. So you see it? There's the 2 x's plus the 8 then as well. Okay? So it's x plus 8 plus x, which is 8 plus 2x. Right? All right. Now, we know the area of this whole big rectangle here is 180. How would we set up the area of this big rectangle? What times what? What are we going to multiply together?
11 plus 2x squared.
11 plus 2x, yep, times, not itself,
8 plus 2x.
8 plus 2x, yep, the other dimension there. Okay, so there's our setup. And what do we know the area of the big area of the picture frame with the area of the picture with the frame? What's that area got to equal? Yes, very good, Olivia. 180, you got it. Right. So then, how can we solve a problem like this? How do we solve this? Well, I'm going to show you two ways. Okay, I'm going to show you two ways. I'm going to do the long way first. I'm going to do the shorter way second. All right? So, but you should know both, so please pay attention for both here. I'm going to show you the first way, okay? The first way involves us getting this into standard form. So number 4, write the equation in standard form, right? We have the formula set up. So I guess just let me pause there. Do we have any questions about where any of these numbers came from? Any questions about where any of these numbers came from? We're all good? Okay, so to put this in standard form, what should be my next step here? What do I actually need to do here now?
Distribute.
I need to multiply. Yeah, we got to multiply, distribute here. Okay, so I'm going to do the 11 plus 2x times 8. Yeah, this is like old times, right? So I'll do 11 plus 2x times 8. So I'm going to have 8 times 11 plus 2x. And then I'll do the 2x times 11 plus 2x as well.
How'd you get 8 on the outside?
Because I did 11 plus 2x times the 8, so I got that. I did 11 plus 2x times the 2x, so I get this. You can do it in a different order if you want to. Yeah, it's fine. Okay. Now, I'll zoom in here some. What do I need to do with this 8? Bless you. Distribute. And distribute the 2x as well. Okay. What's 8 times 11? I'm going to have to go up here. 88. 8 times 2x. 8 times 2x. 16x. 2x times 11 is going to be 22x. Bless you, bless you. You're welcome. And then 2x times 2x, 4x squared, and that all equals 180. Okay.
Just distribute like after the first step?
Couldn't you distribute at the first step?
Yeah.
Well, we did distribute.
I mean like to the right. You know, couldn't you get the answer from the right just from the first?
Oh, like take 8 plus 2x times 11 and 8 plus 2x times 2x?
Yeah.
Yeah, you could do it that way instead if you wanted to, if that's how you prefer.
Makes it easier.
Yep, your choice. Yeah, whatever you're more comfortable with. Yeah. All right, now. Oof, all right, we got to keep working here. We're not done. Is it in standard form yet? What can we put together here? And then 22x. I'm going to put also the 4x squared needs to be in front. So I'm going to put that in front too. And then 16 plus 22 makes 38x. Okay, plus the 88. And I still have equal to 180. Okay? Now to be in standard form here, I need to do one more thing.
Subtract 88.
Not subtract 88. We want it to be equal to 0.
Oh.
So what do I need to do here to make this 0? Subtract 180 from both sides. Yeah. Okay, so that's gone. It's equal to 0. And let's see here. I've got 4x squared plus 38x. And then 88 minus 180 is going to be negative 98, I want to say. No. Negative 92. Thank you. Yeah. Okay. Math teacher can't do arithmetic. Okay. Have we got an answer yet? No. Now what do we need to do? We got to solve this quadratic equation. How do we solve quadratic equations? Well, we could try factoring. Ugh. We could try using what else? Quadratic formula. Ugh. And that's what we're going to do. Okay, I'm going to put it up here, though, because I'm going to run out of room. Okay? So I know you guys... Actually, you know what? I'll do it on a separate sheet of paper here. So let me just show you. We can do this. We can. Okay? So let me just rewrite it here. We got 4x squared plus 38x minus 92 equals 0. Okay? Now let me see here. Whatever. All right, we'll just do it this way. So, negative b. So what's our b here? 38 plus or minus the square root of b squared, so 38 squared, minus 4 times what's our a? 4. What's our c? negative 92, all over 2a. What's our a? 4. Okay, and again, this is x equals here. Okay. We'll make this negative 38. What's this thing underneath the square root called? The discriminant. Ooh, good. Someone besides Sky said it this time. That's good. All right. All right. Very good. Sky, it's okay. That's okay, Sky. Other people got to answer too. Okay. Can you use the bathroom? Why don't you wait? I want to show you this first. The back. Oh, yeah, if you want to put it on the back there somewhere. Ugh. Sorry. All right. I'm going to go ahead and simplify the discriminant. So 38 squared minus 4 times negative 92. I get 2,916. All over 8. Now, you are not going to believe this, but is 2,916 a perfect square? Yes! Oh my gosh. That's actually really nice. It's 54. This is not too much. It's a lot. It's not too much. It's a lot, but it's not too much. Am I going to give you 20 of these for homework tonight? No. I'm going to give you 19. Just kidding. I'll give you like 1 or 2. I'll give you like 1 or 2.
Normally teachers give like...
Right. All right. Let's continue here. I got 2 answers. I got negative 38 plus 54 all over 8. I got negative 38 minus 54 all over 8. Now, I can look at this and see what kind of answer are we going to get when I do this. What kind of answer are you going to get when I do this one? It's going to be negative. Do I need to bother with a negative answer here? No. We are talking about lengths and widths. Negative, throw it out. We'll just do this one. So negative 38 plus 54. I can do this here. 16 over 8. What's 16 divided by 8? 2. So let's get this straight. All right. We had to draw this picture. We added an x onto each side here, so we had 8 plus 2x. We added an x onto this side here, so we got 11 plus 2x. We had to multiply these two sides together because we had area. And we knew it was equal to 180. We distributed here. Combine like terms. Subtract the 180 over. We got this. Then we use quadratic formula over here. Okay? Negative b plus or minus the square root of b squared minus 4ac all over 2a. We simplify. Simplify. We throw out the negative answer. We get 2.
2?
2 is our final answer.
That's it?
After all that. That's it. 2 is our answer. Okay, now.
That was the answer.
Unbelievable.
That's it. That's our answer. 2. Now,
What?
let's back up here. Let's back up. All right, let's go back right to where we had it set up. Let's go back right here to where we had it set up. Let's go back right here to where we had it set up. You can solve the equation from right here if you're comfortable with your graphing calculator. Okay? If you're not comfortable with your graphing calculator, you can do it the way we just did it right here. You can do all this work right here. That's your choice. But let me show you how to do it with the graphing calculator from this step right here. So you can eliminate having to do all this work here if you can just go from right here. Watch. All right, what we're going to do, okay, so follow along with me. I'd recommend you do. Get your calculators out. Okay, if you don't have them. We're going to type in this side of the equation.
Oh my god.
I've been doing this for many years. Okay?
Don't worry, it's not a race.
Longer than you guys been alive, actually, I've been doing this.
No, it's not a race.
Well, so I started using a graphing calculator when I was in middle school, and that was like 96, 97, 98. So y'all weren't alive by that at that point. Okay? So what? How old am I? Is that what you want to know? Hang on. I am currently 34, but I'll be 35 this year. What's that? Yeah. Mine had to go down there. Okay, so, and folks, this is so powerful. Does anyone need a graphing calculator, by the way? I have a few spares. Anyone need one? Sierra, you have a graphing calculator? All right, once you get it out, I'm promising you it's going to be helpful.
Now what do I do next?
Anyone else grab a calculator?
Oh, I got it.
Can you finish? Let me show you this first and let's go. Trey, you grab a calculator? Let's get yours out. It'll be helpful. Okay, here we go. folks, let me tell you something too. If you ever need to solve any equation, you can use this method I'm about to show you right here. Okay? All you need to do is graph the left-hand side of your equation and graph the right-hand side of your equation. There are literally impossible equations. There are equations that you don't know how to solve yet, but you can use your graphing calculator to do it by graphing the left-hand side and graphing the right-hand side. So I'm just going to type it in. Left-hand side in y1, right-hand side in y2. Okay? And let's graph. Okay? So again, here's my two equations, right? There's the parabola we're going to be graphing, but then I'm also graphing this. Okay? Now, what am I going to be looking for? What am I going to be looking for the solution here? Where these two graphs, what? Intersect. Exactly. Now, here's the problem, though. When I graph, how many graphs do I see?
Just only one.
One. We need to adjust our window. Let's go back and take a look at what I'm trying to graph here real quick. I'm trying to graph a y value. This is y equals 180, which means on my window, if I go to my window, the highest y value that I'm currently graphing, 10. So what do I need to adjust this y, or sorry, the y max, sorry. The highest y max I'm graphing is 10. How high do I need to go if I want to see this point of intersection?
190.
Yeah, at least 180. So let's do 190, though, just to be safe. So 190, or 200 is fine, too.
185.
So again, okay. Oh, I see what's going on. So window, and then 190 for your y max. And again, where'd that come from? It's from your, don't worry about the x max. Don't worry about it. Just the y max. Graph it.
Oh, there we go. I saw it.
I got it.
Mine's just a straight line.
Give me your calculator.
And that is a red line.
That's where 180 is.
Okay, now, listen up, folks. Okay. I see one point of intersection, but how many are there actually going to be? There's going to be two. The other point of intersection is happening over here somewhere. If I wanted to see it, what would I now need to adjust?
Well, we had to.
On my window,
X-min.
x min, and so I'm just going to guess like negative 20. Let's see if I can see it now. Okay, so there's more of the parabola. There's my other side of my equation, and now I can see the 2 points of intersection. Okay? So, again, we said the solution to this equation is going to be where the two graphs what? Where they meet. So how can we figure out exactly where they meet? Press second trace. Which command do you think we want to use here? Number 5 for intersect. Go down number 5. Okay, now.
Can you show your window again?
Here we go.
Window, sorry. Let me real quick for Grayson there. You're good?
Yeah.
Okay, go down to intersect. Okay, now you'll see it says first curve. Now you can see it's already selected this one right here. It's my parabola. You can see it listed up there. Or you can also see if you move left and right, you can see it's on the parabola for me. So I'll hit enter. Now it's asking what's the second curve. I can see right here it's already on the other line. If I move left and right, I can see it's up there. So I'll hit enter. Now the guess is going to be important here. Okay? If you want this point of intersection, you got to move your arrow towards that one for the guess. Okay, and then hit enter. And that's when it'll give you that point of intersection. Okay?
Wait, what setting do you do to have that?
Second trace intersection.
There we go.
So, one answer, negative 11.5. But do we want to use negative 11.5? Do we want this as an answer? Does a negative 11.5 make sense for our answer for x? No. So let's find the other point of intersection. Intersect. Again, make sure you're on the parabola. I am. Make sure you're on the other curve. I am. And then for the guess, arrow over. Make sure you guess. You hit enter for the guess near that point of intersection there. Hit enter. Look at that. Do you see that, folks? There's your 2. There it is. Okay? So, option 1. We gotta draw a picture. We gotta set it up, right? Option 1, you multiply it out. You set it equal to 0 so it's in standard form. Quadratic formula. Get your solutions here. Throw out the negative 1. Use the positive 1. Or you graph from this point the left-hand side, graph the right-hand side, adjust your window, find those points of intersection. Okay? Your x coordinate for the point of intersection, that's going to be your solution. And there it is. There's that 2. Okay? It's your choice. It's your choice, folks. Yes, you know. Yeah, okay. Sorry. Sorry?
Seriously, have this straight line.
If you can figure it out a faster way, like guessing and checking or something like that, feel free.
That's fine. You should check out mine.
If you want to use guessing and checking, that's a legit strategy, sure. But I will caution you, if we start throwing in fractions and stuff like that, it's gonna be a lot harder to guess and check.
Yeah.
So you can try a couple of guess and checks maybe, and then, yeah. I'll come. Actually, Mr. Fry's got you there. Okay, cool. All right, let's try another one then. Number 2. Okay, a rectangular lot is being turned into a community vegetable garden, measuring 8 meters by 12 meters. A path of uniform width, some equal width, right? As Anna said, equal width there is to surround the garden. Probably should surround the garden, right? If the area of the lot is 140 square meters, find the width of the path surrounding the garden. So, again, this is another like frame kind of problem. Okay, we've got our community vegetable garden. Okay, I'm going to say that's 8 and that's 12. Okay, there's our community vegetable garden. We're going to add to that a path around it. Okay, another path, a little path around it here. Do we know the width of the path? Are we told the width of the path here? It's just like the last one. You're right. Do we know the width of the path? The answer is no, we don't. Okay, so that's what we're going to say is our unknown. We'll say x is the width of the path. Okay, so that means what's this measurement right in here? X. Okay, what's this measurement right here? Come on, guys. Need you to focus in with me here. Yes, x. Okay, what about this right here? What's this distance? X as well, right? It's x all the way around, and this is x as well. Okay. All right. So then, all right, sky. If this side is 12, right, the interior rectangle here, that length is 12, right? And we're going to put a path with a uniform width of x around it. What will this distance right here be? What do you think? Okay. But what's this length going to be right here? What's this distance? So again, from here to here is 12, right? So we're going to have 12. But then we're going to add on an x this way and an x this way. So it'll be 12 what? Not 12x, nope. We're going to add an x this way. We're going to add an x this way. So how many total x's are we adding? There you go, Sky. Very good. Yep. 12 plus 2x there. Okay. 12 plus 2x. Anna W. What's this measurement going to be right here? You guys got that there? 8 plus 2x. And again, because we have 8 here, but we're going to add an x this direction and this direction, right? We have 8, but then we're going to add an x and an x onto either side there. So it's 8 plus 2x. Okay? Very good. Thank you, Anna. Let's go to Frank. Frank, then, what's the area of this big rectangle going to be? What will we multiply together to get the area of this big rectangle? 12 plus 2x times, sorry? Yes, sir. Very good, Frank. And we know that's going to equal what? What are we told the area of the whole thing is going to be? 140, is that what you said? Yeah. That's right. Very good. Okay? 140. There's our setup. Okay? Okay. So then, if we want to solve this, okay, if we wanted to solve this, then, Braden, what's one option? Oh, he's in the bathroom. Let's go to Alec. Alec, if we wanted to solve this, what could we do? What's one option we could do? Yeah, so we have to multiply this out, okay? Subtract the 140 over, okay, so it's in standard form. You know, put everything in order there, and then use quadratic formula. That's one option. We can do that, okay? Does anyone want me to show it in using the quadratic formula?
Sure.
Yeah? All right, maybe later, okay? I'm going to show some folks with the graphing here first, okay, just so we can get through it. All right? How do we solve this one by graphing? What do we do in order to solve this with graphing on our graphing calculators? What do we do? Put it in. Okay, where do I put it?
The y equals.
Y equals. So I'm going to go to my y equals here. Okay? 12 plus 2x. Oops, wrong space. 12 plus 2x times 8 plus 2x. Okay? What do I put in y2? What's my y2? 140. Okay? Graph. Now, I didn't change my window from last time. Maybe that was not smart, but actually worked out okay. Okay, I didn't need to adjust my window. Okay, because I just used the same one from last time. Okay. Do I need to check both of these intersection points?
Yes.
You can, but we can actually eliminate one of these right off the bat. Which one do we know we're going to eliminate here?
The one to the left.
The one to the left. Because why? What's going to be negative? The y value is positive, right? That's the positive part of the y-axis. What's negative? The x value. Remember, we're trying to solve for x here, right? We're trying to solve for x. Okay, we're trying to solve for x. And a negative width would not make sense. So we're going to find this point of intersection. What do I press to find a point of intersection? Second trace. And I go down to intersect. Okay? For the first curve, make sure you're on one of them. So I'm on my parabola for the first one. That's good. For the second curve, I'm on the line. That's good. Hit enter. For the guess, move all the way over till you're by that point of intersection you want. Hit enter. And look at that. It's 1. You're right.
Curves. Do they have to be the line?
Sorry?
Curve. Do you have to be on the line? Look at my mountain.
For the curve, yes, one of the curves needs to be your parabola. You want to hit enter on that. Then the other curve should be your line. You want to hit enter on that.
What? How can I make it perfect?
What do you mean, how can you make it perfect? Mine is perfect. 140. Is yours not perfectly on there? I'll show you here in a second here. Okay. So what do we get? X equals 1. And in this case, 1 what? We actually have units in this one. We didn't in the previous one. Sorry. 1 what? 1 meter. 1 meter is our answer there. Okay? 1 meter. All right, let me look at yours here real quick, Eric. So what I want you guys to go ahead and do, let's take a look at number 3. Oh, wait, never mind. We got to look at number 3 is a little bit different. Never mind. I'm not sure yet. We'll see. I want to get through another problem here first. All right, Eric, can we take a look real quick? Oh, here. So it's waiting for you to tell what the first curve is. So you want to arrow left and right. And you can see you're on 140, so you're going to hit enter. Now you see it jumps to your parabola, so hit enter one more time. And then for the guess, you want to arrow over, so you're right by that point intersection. So if you arrow to the right there, you can hit right by it. Okay, and then
I don't think they know.
okay.
This is fall out.
Shh. Okay. Let's take a look at the next one here. Shh. All right. Now, guys, if you tuned me out for that last one because you're like, I got number 1, I don't feel like I want to pay attention to number 2, you should pay attention for this one. It's different than 1 and 2. Okay, so make sure you listen up here. Tune me back in, all right? Shh. Number 3, the Smiths have decided to put a paved walkway of uniform width around their swimming pool. Okay, so far it sounds the same thing, okay? The pool is a rectangular pool that measures 12 feet by 20 feet, okay? The area of the walkway will be 68 square feet. Find the width of the walkway. Okay. So let's set this up. Let's draw a picture because, again, it seems like we got a rectangle here. Okay. We're going to put 12 here. We'll put 20 here. Okay, 12 by 20 is what I did it that way. Okay, we're going to add a walkway.
That's so small.
Yeah, I wanted to draw it small because I didn't leave myself very much space, so there you go. Okay, we're going to have a walkway of uniform width around the pool here. Okay. So again, Same kind of question, right? We want to find the width of the walkway. So do we know the width of the walkway?
No.
We do not. So we're just going to call that x. We could, but we don't have the walkway in front of us. So that means this distance will be what? X. We're going to label it as x, right? That means this distance is what? X. And this distance is what? And this distance is x. Now, we are told, and here's where it's going to be different. In number 1, we were told the area of the picture with the picture frame. So in other words, we were told the area of this whole big shape. We were told the area of the whole big shape, right? And number 2, we were told the area of the garden with this path together, the area of the whole thing together, was 140 square meters. Oops, I'm off the screen. Okay? And number 3, we are not told what the entire area of the pool plus the walkway is. We are told only the area of the what? Only of the walkway. So, that's different, right? We only have the area of this piece right here. I'm going to very lightly shade. We only have the area of this right here. This outer piece. That's it. We're not told the area of the whole thing. What would we do here? What would we do to find the area of this? How could we find the area of that? Of this outer ring here? What could we do? So what can we do here to find the area of this outer ring? You'll notice the outer ring is made up of this big rectangle with what taken out? Olivia? Yeah, this is the pool part subtracted out. Okay? So in other words, to find the area of just this walkway right here, we're going to find the area of this big rectangle, and we're going to subtract out this pool area, and that'll leave us with what the walkway's got to be. You see that? Okay, questions on that? That's important to see here. Take the area of the big rectangle, subtract out the area of the small rectangle, and you'll have this shaded area. That's our area that we want. Okay, so let's set up our dimensions here. What is the length of this side going to be? Yep, 20, right? 20 plus an x and an x, so 2x. Okay, what's the length of this side going to be? We have 12, right? And we're adding an x this way, we're adding an x this way. So what's it going to be? 12 plus 2x. Very good, Trey. Yes, good job. Nice. Okay. So then the area of the big rectangle will be what times what? To find the area of the big rectangle, what are we going to multiply together here? Go ahead, Olivia. Yeah, 12 plus 2x times. Beautiful. But we're not interested in the area of the full rectangle here. We only want the area of this piece. So what do we have to subtract from it? What are we going to take away from the area of the big rectangle here? Minus, bless you, minus what? Olivia? 12 times 20. Okay. And maybe I should put it like a dot there instead of an X for the multiplication symbol. Whew. And there it is. So what's the area of our walkway? I'm going to post it to Google Classroom, so I just say check there, Erica. Okay. And so what do we know the walkway? Oh, sorry. What is the area of this walkway got to be? 68. Whew. There it is set up. Okay. So big rectangle, little rectangle. Okay, which is the pool. And this is the pool plus walkway. Yeah, go ahead. Sorry, I just sent. Sorry, Grayson. Why don't you go here in a sec? Okay. Questions on any of that? Okay, I'm not going to sit here, folks, and say this is not easy. I'm not going to sit here and say this is not hard, right? It is. Okay, there's a lot of little pieces going on.
Is it harder than we did that one thing?
I don't know. That's up to your opinion. Okay, but this is what we're asked to do. Okay, this is what I'm asking you to do here. You got to do this. Okay. All right. So we can type this whole thing in our calculator, right? Type the left-hand side in your calculator. Type the right-hand side in your calculator. So I'm literally just going to go, once you have it set up, that's the crucial step, setting it up. You can now just type in 12 plus 2x times 20 plus 2x minus 12 times 20. Okay? Right, there's the left-hand side. The right-hand side is 68. I'm going to graph it. Okay, I don't see the whole parabola, but do I need to see the part of the parabola? Or can I see the part of the parabola I need to see? Yeah, right? I can see my points of intersection. So do I need to check both points of intersection here? No. Which one can I ignore? The left one, the negative one. So second trace, intersect. Okay, I can see that for my first curve, I am on the parabola, so I'll hit enter. For the second curve, I can see I'm on the 68, so I'll hit enter, and I'll go over here for the guess, the one I want. Hit enter. X is 1. Okay? 1 is our answer. 1 foot. 1 feet. 1 foot. Okay? Okay, so folks, you can kind of see here, right, when we talk about these uniform width problems, we're going to be adding an x onto each side, so we're really just going to add 2x to each dimension, right? All right. Oof. We're going to do one more here. We'll do one more. Okay, do one more. And we'll hold off on the flower stuff, the circles. We'll hold off on circles till tomorrow or something. Okay. Circles. All right, we'll get to that one in a second. Okay, I'll answer in a second here. Number 4, let's talk about this last one here. A rectangular garden surrounded by a walk of uniform width. The area of the garden is 180 square yards. Okay, if the dimensions of the garden plus the walk are 16 by 24, find the dimensions of the garden. Okay, so a rectangular garden. Okay, is surrounded by a walkway of uniform width. Okay. Area of the garden, 180 square yards. Okay, sorry, I know I'm writing really small there. So 180 square yards there. Okay, now, the dimensions of the garden plus the walk. The dimensions of the garden plus the walk are 16 by 24. If the dimensions of the garden plus the walk are 16 by 24, which rectangle is that measuring? The dimensions of the garden plus the walk are 16 by 24. Which rectangle is it? The big one or the small one? Garden plus the walk, it's the big one. Exactly right. So we're going to say this one is 16. We'll say this one's 24. Now that's a little bit different, isn't it? Normally our dimensions are measured on the inside, and we're trying to figure out the bigger ones. Now it's flipped. We have the outside dimensions. We've got to find the inside dimensions. Shh. Do we know the width of our walk here? Nope. So we're going to call it x. X is the width of the walk. Okay. So in other words, this distance right here, x. This distance right here, x. This distance right here, x. This distance right here, x.
Find stuff inside and put the x inside the square.
Well, so I see what you're saying, because that's like what we're solving for, you mean? because of the x is the unknown. We're going to get to that. We're going to use this x to help us come up with an expression here. Shh, guys, listen up here. All right, this is different too. Okay, so if this full distance here is 16, right? What will this measurement be right here? Nope. Not just divided by 2. 16, I have to come in how much this way? X, and how much this way do I got to come in? So if I start at 16 and I come in x this way and x this way, how many x's am I really going in? Minus 2 x's, right? I'm going to take an x off here. I'm going to take an x off here. So this, and I can't squeeze all this in here. I'll just put an arrow right here. This distance right here is 16 minus 2x. 16, right, for the full side, take off an x, take off an x. Now we're at this distance. Okay? Likewise, this distance right here would be what? 8. Not 8. This is 24. 24 minus 2x. Oh, I'm sorry. Okay. Yeah, 24, right? But then come in, take in an x, take in an x. So 24 minus 2x. So what's the area of this little inner rectangle going to be? 24 minus 2x times 16 minus 2x. And what's the area of the garden? What were we told the area of the garden was? 180. Okay, so there's our setup. You guys can solve from there. Okay? So, in fact, that's what I'm going to have you guys do. So right now, okay, I'm going to say 4, and I think I got another one here. Let me see. No more. All right, let's do this paper that Mr. Stever's passing out. I'd like you to do number 6 and number 8, please. Number 6 and number 8. 6 and 8, please, for the homework. On this paper right here, Mr. Stever's passing out. 6 and 8. Okay? You found it? Okay.
Is that for homework? The 6 to 8?
6 and 8. Yep, that's your homework if you don't finish it.
6 and 8?
Yes, Alex, sorry. We'll go over those tomorrow. Okay, I'll go over the circle ones tomorrow. Okay, please read the problem. Use the pictures there that are help. They can help you, okay? Label things. Number 6, number 8, though, please. We'll go over number 4 tomorrow, too. Okay, we'll go over 4 tomorrow.